back to my channel. Today I'm going to explain you on topic about ions and radicals. So actually what are ions and radicals? First of all, let's see the first 20 elements. What are they? Hydrogen, H, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. These are the first 10, and sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. Now we all have heard about like H1, H plus 1, H has nothing like 0, lithium minus 1. You all guys have lithium plus 1 actually, not minus 1. You all guys have heard about these, right? These actually, first of all, without any numbers like plus 1 or minus 1, these are neutral elements, which means that they did not even combine with anyone. They have the capacity, but they did not combine with this. These set and there are actually 118 elements, right? These are the first 20. Let's take these as examples, and these are neutral elements. Now here I'm gonna draw one. Like there are we all first of all in this we have the atoms, right? Every single atom. We know that hydrogen. What is the atomic number of hydrogen? H1, right? Huh? Yes, it's H1 and H11. So there are atoms. This is all a atom. Let's take this is a nucleus. First, let's talk about the nucleus. So, what do you guys think about nucleus? Huh? Yes. Nucleus contains positively charged particles named protons and particles without no charge known as neutrons. This is the composition of the nucleus of an atom. Around this nucleus of an atom, there are orbits or shells in which electrons are present. Like this is an example. These are electrons, while these are neutrons. Yes, electrons have negative charge. Neutrons, and these are protons. Again, I'm going to repeat. Protons and neutrons are going to be in the nucleus, and remaining are the electrons that are present in the shells or orbit around the nucleus. Now let's see. Now let's go for hydrogen. What is it? First of all, you guys need to know when an element or an atom becomes stable. Now, first of all, okay. Now, what do you guys think when atom becomes stable? So first of all, you need 100. Let's think that you need 100 rupees to to start any business or buy anything. But you have only 90 rupees. And then your mother or any of your friends have 10 rupees, which you have enough. But you will only buy any shop for yourself and keep it for yourself by taking 1 rupee or 10 rupee from your friend? No. So you both share it. Now, like that only. Let's take this lithium as an example. First, before going to this topic, you guys need to know how many electrons are present in each orbit or shells. This is the nucleus. So, this is the nucleus, right? Around these are the shells or orbits, right? And then they name the first one as K. L, M, so they name the first one as K. Second one K, L, and the third one as M, and third one as N, and fourth one as N. In total there are 7 shells, but first let us know only about the first one. So the electron composition, now K shell, L shell, M shell, N shell. In K shell there are only two electrons since total its capacity of K shell is 2. Capacity of L shell is 8. And M shell also the same, 8. And N shell there are only 2 until 20 elements. So 2, 8, 8, 2. Now this is the structure that you guys need to learn. First of all, to know how an element is gonna get stable or not. I'm gonna leave this here. Now let's step into the main topic. Once wait. Now, we have hydrogen. Let's take hydrogen. This is the nucleus with protons and neutrons, and this is only K shell. Now we have learned that H11, He24, and it's so on, right? Now H11 means this is the mass number, AMU, atomic mass unit, and this is Z, which means atomic number. Atomic number. We have to know that atomic number is equal to the number of protons and is equal to the number of protons is equal to the number of electrons. Repeat after me. Number of the atomic number is equal to the number of protons, which is equal to the number of electrons. So in this hydrogen, in this hydrogen atom, we have 1 proton, and 1 electron. We consider like K this. We consider this K element as and 2882 composition. We consider this as electron distribution or electron configuration. In this one, actually, first of all, each element seeks to get its nearest noble gas electron configuration. Helium He24, right? We know that helium is He24. So, in the case shell, there are two atoms are present, which are sufficient, so they can live like stay independently. But hydrogen only have one in the K shell, only one electron in the K shell. So it seeks to we have two types of hydrogen, H plus 1 and H minus 1. H plus 1 seeks to lose one of its hydrogen atom, and H minus 1 seeks to gain one electron. So seeks to gain one electron so that it gets the configuration of helium. And then it loses. That's another story. Let's leave that. Now, first of all, let's focus on this H hydrogen. It has only one. So, this is the atomic electron structure for hydrogen atom. This is a electron structure for a hydrogen atom. Now, this is not stable. First, let's go for all 21s. Okay. For the combining capacity of an element is known as its valency. What do you call it? Valency. We write the same on the top, like plus 1 or minus 1 or something. But in case of noble gases, they have no valency because they are already stable, having enough number of atoms present in their outermost shell, which is also known as the valency shell. So here H11 it goes for H minus 1 or H plus 1. If at times, tell me this, at times you gave some money or donated charity to the poor, so you will get a good name, right? And then you beg money from others or like take money from others. They say that like this person will be there. He takes some money, right? So it will come a bit bad name, right? So in the same way, helium is He0. Like there's no 0. We don't keep 0. It's He. That's it. Now the lithium. Repeat it after me. Lithium. Metal. This is a scenario which we get plus 1. Means, first of all, any element seeks to get its configuration of its nearest, like what do we call it? Inert gas. So the configuration of its near noble gas is helium, which is K2. Now, lithium has 3. Lithium, this is the structure for lithium. This is the nucleus with 1 and 2, and in the outermost shell it has third one. It has a third one. We all know that 3, like it has atomic number 3, like Z3. So it has three protons, which is equals to 3 electrons. It has 3 electrons, but helium is stable of getting enough a sufficient number of electrons in the outermost shell. But here it has gone for the L shell. It's 8. It's 8. But here there is only 1. What did it say? Only 1 is there. Then what can we do? It loses this electron totally, forming a bond with any other one. So by losing 1 electron, it has got plus valency. It has got plus valency. It has got plus valency. But plus valency, as we have said, that if it has given electron, so it has got plus 1 will give 1 electron. So as it will give 1 electron, it got lithium plus 1. Now beryllium. Beryllium has 2 electrons in its outermost shell. Beryllium, this is K shell, this is L shell. There are 2 in K shell. So, but there are 4 in total electrons. It goes for L shell. It still do, but it's not still enough to go to L shell full containing, which is equals to 8. It's only 2. So it seeks to lose both of its electrons. It seeks to lose both of its electrons, forming a bond, giving it plus 2 valency. Plus 2 valency. B plus 2. Now boron. What did I say? Boron. It has 3 electrons in its outermost shell. K shell 2. In total it has 5. So outermost shell 3. L shell 3. It's still not enough to go for its maximum length. You have seen me saying these elements going for this configuration, but you have never asked, but you might get it out that why can't I just go for these both can go for neon's valency? As neon is not getting it is stable with configuration 2:8 that I will say later. Why? I will ask you one simple question. You have already studied half of a year, not half of a year. You already got some, you got how a algorithm to do a cube. You need to go for fast. But you think that which is better out of this? You already got an algorithm in cube. Decreasing its speed or finding a new algorithm again and again doing it, reducing its speed. What do you prefer? Already gotten one, we think to decrease the speed, right? So these elements go for it nearest elements, nearest noble gas configuration. So these lose electrons. There are, but let's say there are 8. B, is it better to get 5 electrons or giving 3 electrons? Giving 3 electrons is better, right? So it loses electrons. As it will, this boron loses this electron and this electron, giving it B plus 3. Like that, it goes on. I have explained before. Try these, okay? As boron also seeks for this. Carbon. 1, 2. Carbon we have outermost 4. This is a special case I have to teach you guys. This one has 2, 4 electron configuration. But you guys, I told you that B, boron, beryllium and lithium goes for this one, and the remaining 3 except carbon, remaining 3 goes for NO, nitrogen, oxygen, fluorine goes for neon, right? But what happened to this carbon? It has valency 4. That's a special case which we have to study briefly, which I am not going to see you guys now. It's just C4. Okay? C4. This is not 4, okay. C4. Carbon after nitrogen. Here it has 2. Okay. And here we have how much it has? 5 electrons in its outermost shell. Now say, losing 5 is better, gaining 3 is better. Gaining 3 is only better. So, it gains another 3, giving it N minus 3. Now, after nitrogen, oxygen. It has 2 in its cation and 6 in the outermost L shell. It gains 2, so it's O minus 2. And fluorine, it has 2 over here and 7 electrons in its outermost shell. So it has 7. Gaining 1 is better, so F minus 1 or F minus. These are until first to 10. So neon is obvious. I will say you like another ones differently. Like we say it's electron configuration. So it has 2 and here 8 in the outermost shell, which is L shell. It has 8 in its outermost shell. So it is stable. 2, 8. So it's stable. So it does not goes for anything. There is a trick. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. These all elements we can find valency like 1, 0, 1, 2, 3, 4, 3, 2, 1, 0, 1, 2, 3, 4, 3, 2, 1, 0 and 1 and 2. This is simply we can write. This, but without explanation you have big question mark. How do we get that? These are a few that I have explained you, and others are you guys are gonna find them by using this method. Now here I am going to explain you guys electron configuration. What's electron configuration? It is the number of electrons present in its divided according to its shells, KLMN. Until 20 these are only there. So hydrogen there is 1, hydrogen, helium is 2, lithium is 2 1. Here its maximum capacity is only 2, but there are 3. So 2 plus 1, 3. It goes for the addition. So beryllium 2 2, boron 2 3, boron 2 3, carbon 2 4, nitrogen 2 5. Nitrogen you go for 2 5, and here you go for oxygen for 2 6, fluorine for 2 7, and neon for 2 8. Like 2 comma, here commas in between. These are the first 10. And second 10, like sodium, it's 1, like not 1, it's the valency. Sodium here 2 8, so it's stable here. Neon, it has gotten stable. 2 8, I have told you guys, right? So it goes for this shell now, M shell. So Na 2 8 1. Magnesium 2 8 2, aluminium 2 8 3, sodium 2 8 1, 2 8 2, 2 8 3, aluminium, silicon. Even silicon is special case given 2 8 4, phosphorus. Silicon, phosphorus 2 8 5, sulfur 2 8 6, chlorine 2 8 7, argon 2 8 8. This is stable. This is stable. So now it goes for the next shell. Go for N shell. Potassium 2 8 8 1, calcium 2 8 8 2. These are the electron configurations from 1 to 20 elements. Now let's go for radicals. Radicals, actually what are ions? Ions are the positively or negatively charged particles from neutrons, from neutral atoms. From neutral atoms. Like I have told you, right? K plus 1, Ca plus 2, oxygen O minus 2. These are charged. These are charged. But there are few. We divide them like monovalent, bivalent, trivalent, and polyvalent, and so on. So there are positive and negative, okay? Positive and negative. Wait a minute. Now I have told you all of these like K11 and so on. So now let's go for monovalent radicals. Monovalent radicals. Positive. That too positive. Here, in 1 to 20, let's find out. Lithium, it has 1 over here. So lithium. So it's 2, 3, 4. So until here, no. Sodium again 1. Sodium, potassium. These are few examples until 1 to 20. There are many more examples, and these are until now ones. We even have those is negative. These are until 1 to 20. Actually, what are radicals? I have told you radicals. Radicals are also ions. Radicals are also ions. Radicals are also ions. So what? There are two types of radicals: acid radicals and basic radicals. Basic radicals are the radicals with positive charge, and acid radicals are the radicals with negative charge. Here, lithium, aluminium, silver, sodium, potassium, and so on. Now let's go for bivalent. Bivalent. So this is bivalent. These are bivalent radicals now. In bivalent radicals, what do we have? We have like beryllium, magnesium. There are few metals with the variable valency, and I'll say about those later. These iron, silver, copper, and so on. These are only few examples that I am giving you. There are many more examples. Trivalent. Positive. Until now, positive. Trivalent positive radicals. We have boron, aluminium, boron, aluminium, platinum, gold, and so on. We have many, but these are until now. Aluminium, gold, aluminium, gold. Yeah, iron is also there. For monovalent, there is an exception. NH. This exception, let's talk about that later. Trivalent is also completed. Now let's go for monovalent. Negative, like CH3 COOH, not H, CH3 COO minus, acetate, HCO3 minus, bicarbonate, bisulfate, HSO4 minus, and cyanide, Cn minus, and so on. We have a lot of them. I am going to explain you about like how to convert, how to find radicals, how to find what do we say, these crisscross method and bivalent radicals in our second part. Thank you. Please